For decades, recurrent neural networks processed information one step at a time. Then, in 2017, the transformer architecture introduced a revolutionary idea. Instead of reading words sequentially, every word could pay attention to every other word at the same time. RNNs must process each word in order, making training slower and limiting long-range memory. Transformers process entire sequences in parallel, dramatically increasing speed while capturing relationships across long distances. Transformers first divide text into tokens. Each token is converted into a numerical embedding, a dense vector that captures semantic meaning. Similar words naturally occupy nearby regions in this mathematical space. Because transformers process every token simultaneously, they require positional encoding to preserve word order. These position signals let the model distinguish the cat chased the dog from the dog chased the cat. Self-attention allows every token to evaluate the importance of every other token. Instead of relying only on nearby words, the model can instantly connect information across the entire sentence, creating rich contextual understanding. Rather than using one attention mechanism, transformers employ multiple attention heads. Each head learns a different perspective, allowing the model to capture grammar, meaning, relationships, and context simultaneously. Transformer architectures can be configured in different ways. Encoder-based models excel at understanding text. Decoder-based models generate text. Encoder-decoder systems translate and summarize. Together, these designs underpin today's most advanced language technologies. Let's recap. Transformers read the whole sequence at once. Tokens become embedding vectors. Positional encoding preserves order. Self-attention lets every token weigh every other token, and stacking these layers builds the models behind today's AI assistants. Transformers have transformed natural language processing and now influence many other fields. They support translation, coding assistance, education, scientific research, robotics, search, and conversational AI. Transformers learn from massive datasets, but another branch of artificial intelligence learns by interacting with the world itself. In our final episode, we'll explore reinforcement learning, where intelligent agents improve through actions, feedback, and rewards.